okay, you are given an integer n, which indicates that you have n folks, n people, n peeps. Now these n peeps or n people are numbered from 0 to n minus 1. Okay, great. Now basically we have a meeting array. Now that meeting array is decided or like is defined as meeting between two people, xi and yi, at a specific time I. So we have a meeting between two people, xi, yi, at the time of time I. Now we also have a variable called as first person. Now Aryan, why is this useful? We'll know that. Now in the very beginning, there's a secret document or a something which is secret in that company. Person 0 knows that specific secret, and that first person is a lucky person who is like the first person is a lucky person who is already given to us, and the person 0 who already knows the secret in the beginning of the day itself, which means at the time 0 itself, he will tell that specific hidden secret to the first person. So now it's very obvious that this secret is known by person 0 and the first person. I'm not saying person 1, I'm saying the first person, whosoever it can be. First person can be a person 3 also. It is totally up till what the question will give us as the first person. Now my task is to tell you, okay, and yeah, for sure, how the secret is propagated is that we will have some meetings, and in a meeting, if let's say in a meeting room, let's say we have 5 people. Now Aryan, meeting is between 2 people. How come 5 people can come in? Bro, if a meeting is between 2 people, if I am saying, okay, at time 5, I have a meeting between A and B. At time 5, I have a meeting between B and C at time 5. I have a meeting between C and D at time 5. So basically I can say directly, right? I have a meeting between A, B, C and D at time 5 in the same meeting room. That's it. So it is not important that a meeting A will only be between 2 people. It can be between multiple people at the same time also. And okay, and it is easily possible, okay, a meeting AB at time 5, a meeting CD at time 5, it will be in 2 different meeting rooms because these are different people, right? So now it says, okay, if the meeting is happening between in the same meeting room, and if A knows the secret, he will tell the secret to everyone in that meeting room, and at that point of time, everyone in the meeting room will know that secret. So we just, and yeah, it is vice versa also. Let's say if B knows, then B can tell anyone, whosoever is in the meeting room. Now I have to return at the end of all the meetings being done, who all are the list of people who know the secret, right? So that's kind of very normal in your corporate life, right? So basically what will happen in the very beginning, okay, you know that you have 6 people, you know the first person, the person is who knows the secret because of person 0 will be person 1. So I can by default say person 0 and person 1 will know the secret in the very beginning. Now the first meeting, see, at time 0 we have, okay, after 5 minutes the first meeting is held, which means as you can see time is 5. So after 5 minutes from 0 the first meeting is held, in which the meeting is between 1 and 2, and we already know 1 knows the secret, so 2 will also know the secret. Now next meeting will happen later on in the future. Okay, next meeting happens at time 8. In time 8, okay, 2 has already known the secret because of 1. So now 2 is in the state when he knows the secret, he will tell that to 3. Now later on in time, my 10 is a time later on, my 1 already, you know that 1 know, so 5 will also get to know the secret. So you will see that, okay, all 0, 1, 2, 3 and 5 will know the secret. 4 was never in the meeting, so no worries, he will never get to know the secret. Never get to know that secret. Cool. Now what if we have something else, which means in the very beginning my person 3 knows the, so basically 0 and 3 will now know that specific hidden thing. Now at time 3 will be the first meeting. No, because time 2 will be the first meeting, because time is progressive, 0 minutes, 2 minutes. So at 2 minutes time 2 will be the first meeting in which 1 and 2 will meet, and we know that so far only 0 and 3 know the hidden thing. So 1 and 2 in a meeting, both of them don't know, so both of them cannot communicate what is the actual hidden thing. So okay, it is gone. 1 and 2 now don't know it. Okay, next time later in future, time 3, as you can see, 3 and 1 are in the meeting room. Okay, 3 and 1 are in the meeting room. Then 3 and 0 also needs to meet at the same time, so they have to come in the same meeting room. So okay, 0, 1 and 3 are in the same meeting room right now. Now you can see 0 and 3 already know the hidden thing, but 1 don't know, so they will tell 1. Okay, 1 will now also know, and you will see all meetings are over. So ultimately in the end, 1, 0 and 3 know the hidden thing. Now very obvious thing, we will simply have a bigger example and we'll try to incorporate the meetings coming in. One thing for sure is that we incorporate the meeting which came in first. So for sure we will have to go in, and basically you can also say that it is a meeting array, so you have to sort your meeting array on the basis of their time. Meeting which is coming first needs to be handled first. So if my time is this, so I have to handle my time 2 first, then time 4, then time 5, and then time 6. This is I have to go about in my meetings. Okay, great. So I know in the very beginning, person 0 and the first person will be given to you. In the very beginning, person 0 and first person will know the hidden thing. Okay, person 0 and person 1 will know the hidden thing. Now comes the time 2 in which the first meeting is being held. In that time, I know the meeting between 2 and 3 is happening. 2 and 3 are in the same meeting room. But you know that, okay, so far none of them know the hidden thing. So none of them knows it. So basically, okay, nothing happens and we move on to the next time. They both don't know the hidden thing. Now next time is 4. Okay, at time 4 we can see we have 2 meetings happening. 3 and 1, and between 3 and 4. So 3 and 4 needs to come to the same meeting room. 3 and 1 has to come to the same meeting room. So basically 3, 1 and 4 are in the same meeting room. Now we know that, okay, 1 knows the hidden thing, so he will tell 3 and 4. Now because of 1, 3 and 4 also now know the hidden thing. Okay, great. Now 3 and 4 also know the hidden thing. Now next is what? Next is our let's say next is 3 and 4 now knows the hidden thing. Next is 5, 5, 5. So what will happen, or what needs to happen, is that 5 and 6 needs to be in the one meeting room. 5 and 6 and 7 needs to be in the one meeting room. Okay, 7 and 4 needs to be in the one meeting room. Okay, so you will see, okay, all 4 of them needs to be in one meeting room, and I know 4 recently got to know about the hidden thing, so he will tell everyone. So now 5, 6, 7 will also get to know the hidden thing. Now I'll ask you, what did you infer so far? That something what you have to do at a specific time. Again, one thing is for sure, that you will simply sort on the basis of its start time. Now when it is sorted, you will go on to the first meeting. Then you will say, okay, 2 and 3 are connected, right? Which means 2 and 3 know. If 2 knows the hidden thing, then it will tell other one. If my 3 knows, then he will tell the other one. In this example, when I was at time 5, I was, okay, 5 and 6. Okay, so far I tried to tell, okay, 5 and 6 are in one meeting room, 6 and 7 are in one meeting room, and 7 and 4 are in one meeting room. One thing, now because of 4, I know, okay, I can just put all of them in again. Now I'm just trying to find that how I will try to code it up. So I try to gather the requirements. My requirement is 5 and 6. No, okay. My 6 and 7, no. My 7 and 4, no. So basically, technically, I can grab all the elements. Okay, I can grab all the elements at the specific time. I know, okay, 4 is directly connected to my number 7. So I can keep one thing. I can keep the entire person who knows the hidden thing. I can keep all of them in one set. Let's say I keep all of them in one set so as to know, okay, if someone is connected to a person who knows the hidden thing, then he will directly get to know about that specific hidden thing. So 4 is directly connected to my 7. So for sure, my number 7 will know the hidden thing. He will know the secret. I'll say hidden thing. So what will happen is that now my number 7 knows, but what about other numbers? Do I go backwards? Maybe not, because what if here the number would have been 5 and the number would have been 7 here? So I would have gone wherever is my number 7 at the same time. Oh, do you think how this is jumping based on the connection, how it is connected? So basically what is happening, my 4 was connected to my number 7. Then I want to figure out my number 7, who it is connected to. It was connected to my number 6. Then I want to connect it out that, and I want to find out my number 6, who it is connected to. It is connected to number 5. So I have to build all the connections, and when entire connections are built, I know directly that bro, one thing is for sure, that 4 knows it. So everyone who is connected to 4, indirectly or directly, because you can see 4 connects to number 7, it connects to 6, it connects to 5. So anyone who connects to my number 4, directly or indirectly, will actually get to know the hidden thing. So it is more of a connection thing happening. So for sure, we know one thing, that we have to use a graph kind of a thing. We have to use a graph. Now, we just tell me that you have to connect some nodes, like which are already connected or not connected, which means either it can happen that, okay, these two know each other already, and these two know each other already, let's say. Or you can say that these two have a meeting with each other, these two have a meeting with each other. Now, let's say a meeting happens between him and him, and let's say a meeting happen in future between him and him. So now you saw that, okay, a component. Now they all got connected to each other. So basically I'm saying I'm connecting some nodes in some disjoint graph, because you saw it can be a graph, it will be a graph. Now my task is just to connect them. How to connect them? Just to transfer that hidden thing between them, and then I will just, and how to transfer it, just mark them with something. Okay, if they are in one component, because you can see if something is connected, then I can directly transfer the hidden thing between them. So I can just say that it is one component, and I can just directly transfer the hidden thing. Okay, he knows, and I can mark it with something. So I can directly say that, again, in this you can either use simple BFS also, DFS also, and DSU also. But whenever you have some components which are disjoint, and then you have to connect them, make component, remove component, make the component again, and have it as the most efficient time, that can be done by disjoint set union, in which you simply get a few nodes, you try to connect them, and it is not only the nodes, you can connect the entire component itself with each other. That is the power of disjoint set union. Now, if you don't know anything about DSU, union find, disjoint set union, then I will say go watch this video checking existence of edge length limited paths. In this, I've completely, very deeply explained about union find and DSU, like it is the same thing. And if you want to practice it and have a bit more grasp, go and watch this video. Again, both the links I'll try to get that below description. Now coming on back, we know a rough idea that, okay, we want to connect something, and we can use graphs, and still maybe we can use either DFS, BFS, or maybe DSU. DSU is the most optimal one, so as to connect the components, transfer something, add the components to each other. So now we know, okay, we can actually use that with our background knowledge. Now let's see how this will actually happen. So what happened in the very beginning, that in the very beginning, my 2 and 3 will try to connect with each other. 2 and 3 will connect with each other, but we know in the very beginning that only 0 and 1. Again, in the very beginning, my node 0 is connecting to a node 1, which is the first person, so I connected them. Now anyone who connects to node 0 directly or indirectly will know the specific hidden thing, right? Because node 0 or the person 0 in the very beginning knows the hidden thing, and we know that the first person and the person 0 will directly connect at time 0 itself. So I just connected them, and make sure to know if someone knows the hidden thing or not. Just see if he is directly or indirectly connected with your node 0 or not, and that connection to know if 2 nodes are in the same component or not, I can get to know it by DSU. Aryan, why this component came in? You just wanted to know, right? If a node is directly or indirectly connected to your node 0. Yeah, bro. I am saying that, okay, if this is the node 0, and then some graph is there, some graph is there. Now I'm telling you, this is the node 4. So node 4, I will just check in if he is inside the component of my node 0, because if he is under the node 0 influence, for sure he will know the hidden thing, which means who is under the influence of the super senior person, he will know the hidden thing. So I will just check, okay, are they both in the same component? Are they, and when to know the same component, which means if they are connected or not. If they are connected, which means they know the hidden thing. So I'll come back and I'll just simply build a connection between 0 and 1. Now comes that the first time 2. At time 2, my 2 and 3 will try to connect, and okay, my 2 and 3 will try to connect, but you know that none of them is actually connected with the 0. So okay, none of them will get to know the hidden thing. Now actually, now when the meeting over, so you will try to move on with the next time. Next time is 4. But bro, before moving on, please make sure the connection which you have built, now they are no more connected. In a meeting room, it is to connect people, but as soon as the time over, both of them will go out of meeting room now, and both of them will never know the hidden thing, and they are never connect. They never got to connect with their higher message, hidden message. So bro, please disconnect them. Okay, I disconnected them, and you'll get to know why it is important. Because next time what will happen at time 4, my 1 and 3 knows the message, my 3 and 4 knows the message, my 5. Okay, so what will happen is, again at time 4 it is happening, everything is happening. Now 1 and 3 knows the message, so I will connect 1 and 3. Okay, 1 and 3 I will connect. Okay, sorry, 1 and 3 I will connect. Now 3 and 4 I will connect. Okay, 3 and 4 I will connect. So what happened because of this? Oh, so 3 got an influence in the same component as that of 0, and because of 4 connected, and because of 4 connected, again I'll just remove all the edges, and because of 4 connected to my 3, he also got in the influence because of my node 0. So now my 0, 1, 3 and 4 all know the hidden thing. Now Aryan, after you go on, okay, now this this time 4 is done. When you go on to my time 5, will you also remove the edges which you build? No bro, I will not remove these edges. I will not remove it. I will keep it as it is, because now they are connected to the entire main hidden thing. So anyone who connects with them, anyone who connects with 3, 4 or anyone will actually has to also connect to my node 0, because node 0, I can just say, okay, node 0 is the one who knows the parent, who knows the everything. So if you connect with this node 0, you know the hidden thing. So ultimately I'll keep that as it is. Okay, and you will see, because of this, if my 2 and 3 would have been connected, so I would have assumed my 2 also know the hidden thing, but you saw that my 3 met with my 1 after my time 2. That's the reason 3 got to know the hidden thing after my time 2, so he could not tell 2 about the hidden thing. Cool. Now we'll go on to my next time. Next time is 5. At time 5, my 5 and 6 connects, my 6 and 7 connects, my 7 and 4 connects. So my 5 and 6 connects, my 6 and 7, and my 7 and 4 connects. Because of this connection, I know anyone who connects to 4, 3, 1 or 0, you actually get to know. And you know that, okay, 4 knows it, so now 7, 6, 5 also will get to know the hidden thing. Now, okay, let's move on. Now, if we move on, that at time 6 is the next time. Again, I will try to connect my node 7 with the node 9, node 7 with the node 9. I'll try to connect, and again node 9 with the node 2, node 9 with the node 2. Now node 2 also got to know, but it got to know at time 6 because of connecting with the node 9, because of he connected with the node 7, which ultimately connected with the node 4, which connected with the node 3, which connected with the node 1, which connected with the node 0. So you saw, it is how a connection will help us to know if I will get to know the hidden thing or not. Now, although in this picture I showed you that it is a very linear structure, Aryan, if the graph will keep on building like this, then it will actually not help us how to know the hidden thing. Bro, DSU makes sure your graph is compressed at every point. That's the reason we do a DSU by rank. And this operation which we did, which means if someone don't know about, if no one in the meeting knows about the hidden thing, then after the meeting they become disconnected with each other. So we just reset the operation of connecting between them, right? So this operation we can perform if someone we know he don't know the meeting, or he don't know the hidden thing in the meeting. Now it is the exact same thing which we have to implement, exact same thing, and ultimately saying that all these person who are connected, ultimately all the person who are connected directly or indirectly to node 0 will actually know the hidden thing, and that's my answer itself. So the code is also pretty simple. This is the exact same snippet which I have been using in every DSU code. Now if you want to know, it's a DSU by rank. So it's a very standard technique. So this is the exact snippet of DSU I am using. And again, if you want to learn about this, please go and watch these two videos. That will be great for you. Again, one is for practice, one is for just for your theory. Now comes the main part. And as in the beginning I told you that we have some meetings, we have to sort these meetings on the basis of their time. So I will sort the meetings on the basis of a comparator. I have a lambda function right here which will accept two vectors. Now I have to sort on the basis of time is my a of 2. Now if my a of 2, whosoever has a less a of 2 is nothing but time. Whosoever is less, just put that first. If it is same, then put that on the basis of its x. That's a like default thing. That is not required for you also. Main thing is basis sorting on the basis of its time. Now when this portion is done, you are good to start off your actual meetings on the basis of its start time. So I will initialize my DSU. In the very beginning, you know that person 0 and the first person will actually connect to each other. So I just unioned them, as in connected the first person and the person 0. Now I go on to all the meetings, and okay, I know that at a specific time, okay, it is saying that I go on to meeting, let's say at time 4. But at time 4, I want to know all the meetings happening. So time is the current time. At the current time, what all meetings are happening, because it can happen, they can happen in different groups also, or in the same group also. So I'll do one thing. I'll check what is the current time right now. Okay, time is meetings of I of 2, right? Then I will check what all are the people who are in the current time meeting. So I'll just check, okay, current people, who all are there, and the people in the same meeting room will connect with each other. So let's say we have A, B, C, D and B, E. So what will happen? And again, let's imagine they all three are happening in the same time. And again, we imagine that Z was the person 0 and the first person, let's say, was our Y, right? First person was our Y, or let's say first person was our E, right? So in the very beginning, I know, okay, A and again, I will keep on connecting. I will keep on connecting these persons in the same meeting room. I'll connect A and B, right? I'll connect C and D. I'll connect B and E. And now, because of the fact I know that E is connecting to actually Z itself, so these all people will actually know the hidden thing, while these all people will not know the hidden thing because they are not connected to my node Z. So when this entire connection and all that stuff is done, I will say one thing, bro, now what you do is, this is already done and connected to DSU. My DSU helped connect that. But whosoever is not connected to my main thing or the hidden thing, please break their connection. They should not be connected to each other, because in the future it can happen that D might connect to my A, or anyone who knows the hidden thing. So I should not assume that C might also know that, because C connected with my D very first time, in like very earlier, but D got to know about the hidden thing in the future. So please break the connection if someone don't know about the hidden thing. And that's the same thing I'll do. That okay, while my I is less than my meetings dot size, which means while my I have some bandwidth left, then what I will do is I'll simply I know that this hangs a lot, and this actually hangs a lot. Like I have been see, now it went cool. Now what happened is that I is less than my meeting. Now I check while my meeting, all the meetings have the same current time, grab all the meetings and keep on building their connections. So at the current meeting, which is meeting of I, I'll grab those two people xi, yi, and I will connect them by doing a union. And I will also keep on pushing in my current people vector. Now Aryan, why are you pushing those people in the vector? Because bro, I know that at this time all these people got connected, which means I know at this time A, B, C, D, E got in the meeting, but I know only A, B and E are the people. I know only A, B and E are the people who know the hidden thing. So whosoever don't know it, which means in this case C and D, I need to disconnect them with everyone else because they don't know the hidden thing. Connection will only be built for the people who know the hidden thing. So what happened here is I am building connection for everyone without even thinking. They might know or might not know the hidden thing. So I For that reason, I also keep on pushing all these people in my current vector. Now, when I have built the connection, and I will keep on trying until my time is same as this current time. Now, when this is done, which means for the current time, I have tried to connect all the people, and then I will go and check for all the current people which I connected for the specific time above, which was CT. I will again go and check, bro. Was that person connected to my node 0? Again, this is a O of 1 operation. This is a O of 1 operation, right? So this again, union and amortized O of 1. It is a very, very, very well proved thing that this connection, find, union, everything is O of 1 operation. So he will go and find, bro, this current person, does he know the hidden thing? And I can get to know if he is connected to my 0 or not. If he is not connected to my 0, which means for sure he don't know the hidden thing. If he don't know the hidden thing, bro, reset him. What I mean by reset is something new which I have added in my DSU. Now this reset says, bro, simply assign my parent of node to node. Aryan, but how do you know that you have to assign this thing in a reset? Because in your DSU code snippet, which you have taught earlier, you have only showed the initialization, find, and union. You have never showed reset. So what is this reset? Bro, reset, as you can see, while initializing itself, you assign parent of I to I, right? Which means parent of node to node. So reset is same, initialize it back. So I reset my node, which means parent of node is node itself. That is what I mean by initialize or reset itself. So that just saying, now it is not connected to anyone else. It is reset. I just reset that specific person. But I'm not resetting the ones who are already connected to a node 0, because I know that they know the hidden thing. Anyone connects to them also should know the hidden thing. So I'll keep on trying this entire thing. Until I can do it. Now, ultimately in the end, everyone who would know the secret will actually be connected to node 0 by any means. And the persons who don't know it will actually be different like this. So ultimately in the very end, to know finally who all know the hidden thing, I will again iterate on all of the numbers. I will check if my find is like 0, if I can find that specific I in the same component as that of node 0, bro, please, that person I knows the hidden thing, please push that in my answer. And thus I'll push back in my answer, because I know 0 is the one who knows it. So just check in that component itself. That's it. And by this you can simply get this solved. Again, the time, because of sorting, it will take O of n log n, because you know that you did sorting. So it is O of m log m. And the same way you are here using and iterating on the meeting, it is O of m operation. This is again O of m itself, because here I is keep on increasing. This I thing, it is increasing in this loop. So these two loop is actually O of m itself. This DSU union and find operation, both of them are O of 1 operation. Make sure that again amortized O of 1, and that is actually O of 1. Now ultimately in the super end, what you do is you again do have a O of n operation. So ultimately I can say the time capacity is O of m log m plus m into 1 for DSU, and plus O of n. And space is again O of m plus O of n, again O of m, because you are pushing back in the vector all the people at the same time, and it can happen that all the meetings are happening at the same time itself. So you might end up pushing everything in the vector, all the m meetings people. So it can be O of m because of that. And you know that the graph will DSU itself will needs to initialize with something, and that is O of n itself. So your DSU will take O of n space. And this is again, as in the beginning I told you, it can be solved by BFS, TFS, improvised BFS and DFS also, but this is the most optimal and the most intuitive approach to solve this problem. Cool, thank you for watching. Bye, take care, bye bye.